small scale and local wind systems for ESCI 211, Chapter 9, Part 4. So today we plan, at the end of this online lecture, you should have a better understanding of what a sea breeze or a land breeze is, water effects on wind patterns, or bodies of water effects on wind patterns, and seasonal changing winds, and mountain breezes and valley breezes, and then also something called a katabatic wind. All right, so let's get started for today. All right, so let's review our local wind patterns again. And so we have a body of water here and land here. The sun comes up, the sun's rays heat the surface, right? But land has a smaller specific heat. Okay, it's smaller than water's specific heat right here. All right, since it's smaller, the temperature on the land should rise faster than the temperature of the water, and so the land will become warmer and create a thermal low, and the air will rise. The water will be cooler, so it should create a thermal high, and the air should sink, and we get this pattern right here. Since the wind is blowing from the water onto the land, we get what is referred to as a sea breeze, or if it's a lake, if the body of water is a lake, we call it a lake breeze. All right, so that is one type of local and how the local circulation pattern is created. Now, in the evening, the sun is gone, and there's no energy being put into the land or the water, but again, the land has a smaller specific heat than the water. Okay, so that means it should have a faster change in temperature than the water. So the air over the land will be cooler than the air over the water, and so the air over the land will create a thermal high, and over the body of water we get a thermal low, and we get an air pattern that goes from the high to the low, and then again above up in altitude above the land, or sorry, the water, you'll get a thermal high, and you'll get this circulation pattern showing up again. Now, since the wind blows from the land to the water, this is called a land breeze. All right, so let's ask a question here. What happens to the friction as wind travels over water? Well, okay, let's look at that. We've got some land here and a smooth lake, and as the wind goes over the water, we have friction here on the land. Okay, so we have friction here, but when it gets over the water, there's no friction, so we're going to get an increase in the speed of the wind because there's nothing slowing it down. But then when it hits land again, it's going to get more friction, and then it'll slow down again. All right. So when it does this, what happens is, so I've got this slow moving air here, and then I have fast moving air. So I can take more air out than I can bring in. So we're going to need more air, and the way we get it is up the top of it. Okay, and this is, so we get what we call a divergence zone right here on the edge of the land and water interface. Now the opposite happens on the other side. We've got more wind, since it's moving faster, we got more wind coming in than that leaves over the land. So we have a convergence zone. So all this air is piling up, and I got to get rid of it. And the only way it can go is up, so it rises. And then if it rises high enough, it can cool and form a cloud. And that's how one way wind can affect a body of water can affect wind. So it can change its speed. Now, why would the wind change direction over the water? As we see in this picture right here, it's changing direction. And the answer is this: since the water has less friction than the land, so the wind speed will increase. This will cause an increase in the Coriolis force that will turn the wind to the right in the northern hemisphere. It'll turn the wind to the left in the southern hemisphere. And so that gives us our change in direction until it changes enough to until the frictional force and the pressure gradient force and the Coriolis force all add up to be 0, and then it'll straighten out again. All right, what kind of seasonal wind changes do we have? Well, in India, they're quite common. They're called monsoon winds, and these are a type of a sea and land breeze. You have a summer monsoon and you have a winter monsoon season. Here, we'll show what these are. Okay, so here's the winter monsoon. This is over the Himalaya mountains, so they're high up in the air, and so that means the temperature is cooler, so you have all this cooler air, and if you get enough of it, it will spin down over and roll down the sides of the mountains out into the flatter regions, non-mountainous regions, and then out over the ocean. Now, the low pressure system here, the summer monsoons, are created in summer because the sun's out more often and heats up the land mass, okay? And so this is going to create all this converging air flowing in, and the only place the air can go is up. Okay, so then that air will go up. So what the air is coming in is very moist and warm, and as it goes up, we know it should cool, form some clouds and rain, and this can produce some really large amounts of rainfall in a short period of time. We're talking 6 to 12 inches within a couple hours. Now the winter monsoons, these winds are very dry and cold. These tend to dry out the land a little bit more and cause more forest fires. All right, another type of local wind system is called a mountain breeze or a valley breeze. So it's another example of the thermal circulation system. The sun will warm the valley air, and this warm air will rise up the slope. So this is called a valley breeze, or sometimes an upslope breeze. Okay. Now, in the evening, when the sun's not there, you don't have the thermal heating of the valley and warming it up, but the air up high on the mountain is colder than the air in the valley, and it's more dense. So what's going to happen is it's going to flow down the valley, or flow down the mountain into the valley on both sides, and this is what we call our mountain breeze. All right, here's another type of wind. So it usually happens on high plateaus in the mountains. So this happens near mountain ranges, so the Rocky Mountains, the Himalayan mountains, the Andes mountains, all the different mountains across the globe. What happens is you get the cold air in the upper high latitudes, and usually there's a snow cover. It usually happens when the winter season, and so you get a high pressure system here, you get a low pressure system over the valley. The pressure gradient force wants to move this air from the high to the low, and so what happens, it spills out of the plateau and down the mountainside into the valley. And this is sometimes referred to as a downslope wind, and it's much stronger than a mountain breeze. You can get very strong winds, sustained winds for long period of time. It's like 20 30-mile-an-hour winds for 24, 48-hour periods or longer sometimes. These katabatic winds have certain names depending on the regions you live in. So the eastern slope of the Rockies, Colorado, New Mexico, Nevada, have what they call Chinook winds. Out in California, Los Angeles area, they have them called the Santa Ana winds. And these tend to enhance the fire threat in those areas, and you get these massive fires that you hear in the news. In North America, on the eastern seaboards, you get these systems called nor'easters that are created by katabatic winds. And even in Texas, you get what's called Texas northern winds. And even in Colorado, in Boulder, Colorado, you get these winds called boulder winds that come out of the mountains, the cold, high plateaus of the mountains, down the mountain slopes into the valleys. All right, so I hope after this online lecture you have a better understanding of what we call a sea breeze or a land breeze, how it's created, and which way the wind flows, what causes these breezes, the difference between land and water that helps enhance these breezes. I hope you have a better understanding how water affects wind patterns. It can increase its speed and change its direction if the wind flows over water. I hope you have a better understanding of seasonal changing winds, these katabatic winds, what causes those, what causes mountain breezes and valley breezes, and also what causes the what are called katabatic winds, and knowing one or two of the type of katabatic winds that occurs across the globe. Well, that's the end of chapter 9, because this is part 4, and I'll see you in chapter 10.